Let's take a look at inner class example. Here's a data structure Java. Okay, let's copy this, paste in Eclipse. Add a package. Okay, this data structure demonstrates the usage of inner classes. In the constructor, we initialized an array of int. The array has 15 elements, and we initialize them with a natural number from 1 to 15. In the print event, a iterator is iterated through, and we're just trying to print out the even number in the array of the ints. So let's take a look at this iterator. Iterator is an event iterator. It implements a data structure iterator which extends iterator. So this is actually a bridge. We didn't add or remove or modify or override any abstract methods defined in the iterator. This example shows an inner class can implement an interface. Can implement an interface defined in itself, or it can implement an interface defined somewhere else. So let's just remove this bridging. Okay. It didn't change anything. In this iterator, it implements the hasNext and the next. HasNext tell if we are at the end of the array. If the next index below the size -1, like above the size -1, we know we are at the end of the array, and hasNext return false. In the next, we keep getting the value of the array. After we get the value of the array, we return it. Before we return it, we advance the index by 2. That's why we print out the even number. This is the main function. We create data structure and we print. So if we run the program, we print out all the even numbers. We don't have to pay too much attention to the iterator. OCPJP didn't mention it in the syllabus. And nowadays we use for loop, we use stream. Iterator is no longer emphasized. What we need to pay attention is how to create an instance of the inner class. Here we use a new keyword. The new keyword is accessed through the enclosing classes instance. So this reference to the calling instance. Of course, we are already in the print event. Whoever calls this print event is the object this reference to. So we can remove it. The code will still work because this just means whatever object calling this method, which is an instance of the outer class. We can remove it. If we are outside the enclosing class, we need to access a new keyword through an instance of the outer class. Okay, that's a point we need to pay attention. Other thing we need to pay attention is even the iterator can be private. Of course, it can be public. It can be protected, or you don't need anything. Use a default modifier. So all the modifier is okay for the event iterator. You use private so that outside the enclosing class, you can access this inner class. Another thing OCPJP will test is inner class can implement any interfaces. It can be final, or it can even be abstract. Of course, if abstract, you cannot use new to instantiate it. However, if you have another private class, okay, inner class, event iterator, e extends event iterator, and it's not abstract. And now you can have you need a public void event iterator e. You cannot instantiate this, huh? What's going on? That's abstract. Cannot be served to a type. Even iterator e. Are they okay? Now they're name match, and so it can be an abstract. In the inner class, we cannot have static field. Let's say int a equal 10. This is not allowed. The error message says the field cannot be declared as static in a non-static inner type. So you cannot have the static variable in the inner class. This is not allowed. What's next? Let's go back. Local and anonymous classes will be mentioned later. Modifiers already mentioned. They can be private, public, protected, and default.